Good day everyone, I am Emeline Espanta and I am a BSc student and 3A. I will be discussing my solutions for the short exam given on the module 4 on our electrical machines subject. So the short exam states that a 200 volt shunt generator has an armature resistance of 0.02 ohm and a shunt resistance of 44 ohms. At rated load, the driving engine develops a 62.25 horsepower, and if the iron and friction losses amount to 1600 watts, so how much is the current delivered to the load at the rated condition or at this rated conditions? My solutions, I have stated the given. So we have a value of our VL, which is 220 volts. We have the value of our RA, which is 0.02 ohms. We have also a given value for our shunt resistance, which is 44 ohms. And at rated load, it was stated in the problem that the driving engine develops 62.25 HP. So driving engine means P input. So we have 62.25 horsepower. And we know from our previous lessons that 1 horsepower, the conversion of horsepower to watts is 1 horsepower is equivalent to 746 watts. So we have also a given that the P iron and the P friction has a value total of 1600 watts. And we have to find the current delivered to the load, which is denoted as IL. So this is a shunt illustration, a shunt generator illustration circuit. So we have PL. First, we get the value of our PL. So we have PL is equal to IL times VL. And we know that we have a given value of our VL, which is 220, and we don't have yet the value of our IL since we need to get its value. So we conclude this as our equation 1. So proceeding, we get the value of our shunt power, or the P shunt, which is equal to the shunt current squared times the shunt resistance. So we are given a value of our shunt current, which is 5 amperes, and we have the shunt resistance, which is 44 ohms. So we get a value of 1100 watts. So proceeding with our solution, we have shunt current is equal to VL over shunt resistance, or the ISH is equal to VL over RSH, or the R shunt. So that you may be wondering that I have put here VL instead of V shunt. So VL is the same with the V shunt, since the voltage that drop on the load reflect or mirror on the voltage that drops on the V shunt. So that is why, since VL is already given, why not use it? So again, we have the given already, so we proceed in getting the shunt current. So we have shunt current of 5 amperes. That is why I have put the 5 amperes on the power shunt, or the P shunt. So proceeding, we have PA is equal to IA squared times RA squared, or the armature power is equal to the armature current squared times the armature resistance. So we know that the armature current is equal to the, using KCL, we have the shunt current plus the IL. And we now have the value of our shunt current. So, and still, we don't have the value for our IL. So, we use this IA is equal to 5 plus IL as our equation 2. So, proceeding on the solution, we have P input. We know that P input is equal to PL plus P shunt plus P armature plus P losses. So first, we convert the value of our P input. So P input is given, so we have 62.25 HP. So we convert it into watts. So 62.25 HP times 746 watts over 1 HP. So canceling the HP, can get a value for our input in watts, which is 46,438.5 watts. Since we have already the equation, we have three equations. So using the equation 3, we substitute equation 1 and equation 2 and the other given values to our equation 3. So we have P input is equal to PL plus P shunt plus P armature plus P losses. So we converted already the value of our P input, which is 46,438.5 watts. So we substitute the given values on the equation. So we have 46,438.5 watts is equal to 220 times IL plus 1,100 watts plus IA squared times 0.02 plus 1,600. So we know that IA is equal to 5 plus IL. So we substitute the value of our IL so that we will remain only a variable, which is IL. So now we have 46,438.5 watts is equal to 220 times IL plus 1,100 watts plus 5 plus IL squared. So this 5 plus IL squared will expand using algebra or simplify. We simplify or expand this 5 plus IL squared times 0.02 plus 1,600. So for further simplification, we have now 46,438.5 is equal to 220 times IL plus 1,100 plus 25 plus 10 IL plus IL squared times 0.02 plus 1,600. As we are able to simplify the equation, we can conclude that we have 0 is equal to 0.02 IL squared plus 220.2 times IL minus 43,738. So using quadratic equation, we can obtain a value of our IL, or the unknown variable. So we input the value of our B, which is 220.2, and then we have the value of our A, which is 0.02, and then the value of our C, which is the constant, which is 43,738. And then as we simplify the equation, we can get two values, a positive and a negative. So we choose the positive since IL shouldn't be negative. So we conclude that the IL is equal to 195.17, which is This is the current delivered to the load at this condition. So we have now the value of our IL. So that is all. Thank you.